Hello guys, in this video we're going to be looking at how to add and subtract mixed fractions. So fractions that have a whole number and another fraction next to it. So in this case we have 1 5/7 plus 3 and 2/14. Now notice guys what we covered in the previous video. We had to make sure that we have the same denominator. Same thing applies here. So again, I want you to write a little note to yourself just as a reminder. We want to get the same denominator. So 7 and 14. The easiest way to get those to be the same denominator is to make the 7 a 14, and I can do that by multiplying that by 2. Now notice I'm only going to be multiplying this part of it. The whole number, I'm just going to pretend like it's not there. So I go ahead and multiply that part. I have 5 times 2, that's 10, and 7 times 2, that's 14. So now I have 1 and 10/14 plus 3 and 2/14. Now when you're adding these guys, I actually want you to set this up as if you were adding regular whole numbers. So keeping in mind place value. In this case, I have my whole numbers here. And then I'm going to go ahead and write next to it the fraction part. And I'm going to add just as if I was adding regular numbers. I'm going to add the fraction part first and then my whole numbers. 10/14 and 2/14 gives me 12/14, and a positive 1 plus a positive 3 gives me 4. Now I do not want to leave it like this because this is not simplified. So to simplify guys, we're going to go ahead and that will be my last step. This 12/14, it's both divisible by 2. So that's going to give me 4 and 6/7. This would be my final answer for this problem. Let's go ahead and go to the next example, guys. We have now 5 and 2/8 plus 7 and 5/18. This one's a little bit harder. We have difficult denominators that we have to deal with, but we can do it now using our prime factorization that we talked about. Okay, prime factors of 8 and 18. The factors of 8 are 4 and 2. 4 can be broken down into 2 times 2. 18 would be 9 times 2, and that can be broken down into 3 times 3. So if I write the least common multiple of those, I would do the following. I'm going to write these first. 2 times 2 times 2. I'm going to write these underneath. I have this repeated, so I write it underneath that last 2 times 3 times 3. So the common multiple of these is going to be 2 times 2 times 2 times 3 times 3. So that's going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 3, that's going to be my least common multiple. This is going to give us 72. So I want to make, so I need to ask myself, how do I get my 8 to become a 72? And to get there, I'm going to be multiplying by 9, top and bottom. And now this 18, to figure this out, guys, I'm actually going to go back down here to take a look at what was happening here. Okay, the 18 is these numbers, a 3 times a 3 times a 2. If I circle them, the only part that I'm missing is this part. This part's going to tell me what number to multiply 18 by to get the 72. I need to multiply by 4. So I multiply by 4, and I'm going to be able to get that answer. So I continue, guys. I remember I keep the whole number the same, multiply the rest. 9 times 2 is 18. 9 times 8 is 72. 5 times 4 is 20. 18 times 4 is 72. And I'm going to go ahead and set them up one on top of each other, whole numbers together, fractions together. and I'm going to go ahead and add straight down. So 18 plus 20, that gives me 38 out of 72, and 5 sevenths. Now remember, I would try to see if I can simplify this. So both of these numbers are divisible by 2. Sorry, hang on. I should have added 5 and 7, not 5 sevenths. So 5 and 7 gives me 12. So there we go, I have 12, and then 38 and 72 are both divisible by 2. And so this would be 12 and 19/36. And that I know for sure is not divisible by anything else. And our last problem, guys, 6 2/3 minus 3 5 sevenths. Okay, this one is going to be a little bit difficult because we're going to have to borrow, and I know it's hard to see how you're going to borrow with fractions, but I'm going to show you how to do that. So first things first, get the same denominator. In this case, they're both prime numbers, so they're already in prime factorization. I need to multiply by each other to get the same denominator. So I'm going to get 6 and 14 over 21 minus 3 and 15 21s. Okay, so same thing, guys. I'm going to set them one on top of each other. So 6 and 3 are my whole numbers, 14 21s and 15 21s. Okay, let's go ahead and subtract, and let's see what happens. When I subtract these, I end up with a negative 121 and a positive 3. Okay, I can't write this as 3 negative 121. This does not make sense. Okay, but what's actually happening, guys, if I was having 3 1/2, that's the same thing as 3 plus 1/2. Sorry, 1/3. In this bottom, the same thing is happening. I have 3 plus a negative 121. So how do I do that? Let's break this 3 into a 2, and one of the wholes, I'm going to break it down into 21 over 21. Okay, if I'm subtracting 121, what's actually happening is I am getting this minus 121. That gives me 20 21s, and my whole number, which was 2. So that's actually 2 and 20 over 21. And that is not divisible by anything, so that would be my final answer.